So let me touch on the important parts of WebAssembly versus SignalR from an architectural perspective. Invariably, if you've looked at Blazor, then you've heard over and over and over and over again, server-side WebAssembly, server-side WebAssembly. But let's talk about how to think about that and how to really decide which one is going to be more appropriate for you. So it's not just, oh, you have these options, but no, you can really decide you should use one or the other. So in Blazor server-side, remember that the only Blazor application, the only code that is actually running in the browser is a JavaScript file that Microsoft built, blazor.js, and that is the Blazor application that is running in the browser. And when someone goes to the URL, they're downloading that JavaScript application, that JavaScript file, and running it. And then that JavaScript file, the code in there immediately is going to establish a WebSocket connection back to your server, wherever it happens to be. It could be app service in Azure or just a running process somewhere on a test environment. It doesn't matter where. And then your Blazor app, your C#.NET process on the server side will be able to constantly push information up to that JavaScript application that's running. And the JavaScript application is going to manipulate the DOM, the document object model, in the browser, adding elements, removing elements, changing elements in the browser itself. And so if you hit F12 and you look at in Chrome or Edge and you look at what's going across the WebSocket connection, you're going to see all these little binary messages. It's really chatty, really chatty. And you can't really make sense of it, but that's what is actually being communicated between the client and the server. And so if you've never hit F12 and looked at your WebSocket connection, just go ahead and glance over there just to see every time you click a button or do something, you're going to see a flurry of these little back and forths. Now, they're really tiny. They're not text. They're binary. So they're small, compressed, and you can see the size here. Is measured in number of bytes, and the framework itself is going to have chattiness back and forth. But when you actually send some data transfer objects, maybe you get from a query to your database, and you send it up. Actually, correction, you never actually send that up. You actually paint some HTML on the screen, and then the framework makes a diff of the screen, and then that data gets sent up. Because all we're doing is adding HTML elements to the screen on server side. And so think about that, because there are a lot of round trips, but they're small, okay? So raw speed is not going to affect the perception of snappiness of your application. However, latency and jitter will. So go ahead and measure latency and jitter if you're thinking about server side, just to see if you have a network topology that's going to be compatible with this. You don't need the raw bandwidth. Okay, if you're making now flip it over to WebAssembly, you are running .NET in the browser, and if you're going to call over to a web service and say, hey, give me the results of this database query, and then that information is going to be packaged up as probably JSON, and then thrown over the wire, then all of that raw data is coming over the wire. And so if you have what effectively is a select all from this table, and you have 50 columns in that table, well, you're going to get, even if you're using Entity Framework, you're going to get all that data. You're going to pull it over the wire. And then let's say you only use 5 for a particular screen, you only use 5 properties of the object that's hydrated with that. You are going to have pulled over all that data over the wire, and then you only use five fields. And so it's a lot of waste. And so in those cases, you would need to make sure that you have sufficient bandwidth, because you're going to be a little bit wastefulness on raw transfer. However, when it comes to jitter and latency, you actually only incur the latency one time because you made a web service call and then you got it back. Now, in reality, depending on the size of the data, because you're using transfer control protocol, TCP, there's going to be a lot of different packets going back and forth. And so you are going to incur the latency multiple times, but not nearly as many as the chattiness of server side. And so when you're thinking about it, we have seen in the real world scenarios where whether it's in situations where the Wi-Fi is just kind of spotty up and down, whether it's jitter, whether it's latency, we could be clicking on a button and the only thing that we need is to type the word okay on the screen, and the server side just not being able to have a snappy experience, because there is, other than just writing raw JavaScript, which you can, other than writing raw JavaScript, we need that round trip to the server in order to even paint a response to the user, to even let them know that their button click was registered. We have to get to the server and round trip. And if you're on the West Coast and then your data center is on the East Coast, you know, you're getting, what is it, between 10 and 30 milliseconds sometimes, just to jump across the country. So you have to think about that.